Hello and welcome to our video tutorial. Today we're going to look at Unit 5, Lesson 2, Slope and Perpendicularity. Please remember to pause or rewind the video as needed. Let's begin. A couple of things to note before we begin. Two lines, if you recall, are parallel if they have the same rise over run slope. Two lines are perpendicular. That means they intersect at a 90-degree angle if and only if their slopes are negative reciprocals of each other. Okay, so what does that mean? So let's say I call this line 1 and then this line 2. The slope of line 1 has to be a negative reciprocal of the slope of line 2. Okay, so what does a negative reciprocal look like? Well, it means take the reciprocal and turn it from either positive to negative or negative to positive. Let's see how that plays out in number 1. In each of the following, if each of the following represents the slope of a line or a line segment, give the slope of a line that is perpendicular to it. So what I'm going to need to do, a perpendicular slope to this would be the reciprocal and a negative version of that. So slope for a perpendicular line here would be the reciprocal of 4/3 is 3/4. And since this is positive, I would make this negative. So it's reciprocal and then change the sign. Okay, so same thing here. Reciprocal, that's 7/3. Change the sign from negative to positive. Okay, here, the slope is 4/1, so a negative reciprocal would be 1/4, and then change it from positive to negative. D, the slope would be 3/1, and we change it from negative to positive. And by the way, the symbol we're going to use for this, the symbol, an upside down T, is the symbol for perpendicular. And two lines that are right next to each other, it's not the number 11. Those are two parallel lines. That's the symbol for parallel. Okay, so the perpendicular slope, I'm going to write M with a subscript perpendicular. The perpendicular slope is, in this case, negative 3/1. I'm just going to write it as just 3. All right, and then same thing here, the perpendicular slope for this. Now this would be 1/1. So take the reciprocal, it's still 1/1, but you have to change the sign. Number 2, if a line passes through the points E, -1, 4, and F, 3, -2, which of the following is a slope of the line that is perpendicular to EF? Well, the first thing you got to do is find the slope of the line that passes through those 2 points, and then we're going to do a negative reciprocal to find the perpendicular slope. Okay, so x1, y1, x2, y2. We're plugging into our slope equation, y2 minus y1, over x2 minus x1. Okay, we're going y2, -2, minus y1, 4, over x2, 3, minus 1, 4. So -2 minus 4 is -6, over 3 minus a minus is 3 plus 1, or 4. Well, we get to divide top and bottom by 2, because that's the largest number that goes into both, and we get -3 halves is your slope. Okay, -3 halves. So the slope that is perpendicular to this would be the reciprocal of 3 halves, which is 2/3, and change the sign from positive to negative. So the perpendicular slope would be positive 2/3. A line segment whose endpoints are 3, 9, and 7k, so x1, y1, x2, y2, is perpendicular to another line whose slope is -2. So let's hold on. So the perpendicular slope to -2 would be the reciprocal of -2 is 1 over 2, and then you change the sign from negative to positive. So positive 1/2 is the slope of the perpendicular line, okay? And these 2 points lie on the perpendicular line. So I'm going to use my slope equation here, okay? And so y2, that would be k, minus 9 over 7 minus 3 equals your slope perpendicular, right, which is 1/2. And what we're going to do is we're going to solve this equation for k. All right, so now the easiest way to solve this thing is just like any other proportion, go ahead and do your cross product. So this would be k minus 9 times 2. So k minus 9 times 2 equals 7 minus 3 times 1, which is just 7 minus 3, so I can just get rid of the parentheses. Okay, I'm going to distribute through parentheses. Actually, no, I don't have to. This is going to be 4, and I get 2 times k minus 9 equals 4. Go ahead and divide away the 2. It'll actually get us there faster. K minus 9 equals 2, and then we can go ahead and add 9. The value of k would be 11. Number 4, given that the line graphed on the grid shown, which of the following would represent a slope of a line perpendicular to m? So first, let's find the slope of m. Okay, so what's the slope of m? Well, I'm gonna pick a point. Okay, there's a good point right there, and I'm gonna go to another point that crosses. So we got to go down 2 over 1, 2, 3, 4, 5. That's a slope of -2/5. So slope that is perpendicular, a negative reciprocal of that, would be changing the sign from negative to positive, and then take the reciprocal, which would be 5/2. Okay, let's move on to the second page. Number 5. On the following grid, AB is shown along with point C. Draw 2 lines on this grid to pass through point C. One of them is parallel to AB, the other is perpendicular to AB. So what do we need to do? We need to find the slope of AB. So first let's do that, okay? So line segment AB, okay, the slope is, okay, and we're using our slope equation. If you don't know it, write it down. Okay, now, actually, no, we don't need to use our slope equation. I'm sorry, we have a graph. So let's just use our rise over run model. Okay, that'll be faster. And we're going up 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Going up 8 over 12. Go ahead and the largest number that divides into both of those would be a 4. Okay, so we are going 2 over 3. So we have a slope of 2/3. Now, here's the thing. A parallel line also has a slope of 2/3. A perpendicular line, the slope would be a negative reciprocal. So take the reciprocal of 2/3 and we get 3/2. Negative reciprocal means change the sign from positive to negative. All right, so here's how we're going to do this. We're going to use point C as our reference point. So I'm going to go, if I have a slope of 2/3, I'm going to go from point C up 2 over 3. So up 1, 2 over 1, 2, 3. There's my other point. And I'm going to draw a line through those just like that. Okay, and there's the parallel line. Let me do that in a different color just to make it stand out a little bit. Okay, and then now the perpendicular line, I'm going to go down 3. This is from point C, mind you. Down 3 and over 2. Let's use a different color. Let's go orange. Okay, so I'm going to go down 3, 1, 2, 3, over 2, down 2. That puts me right there. Down 3 over 2. Okay, so you can see that the orange line is perpendicular to AB, and the blue line is parallel to AB. Okay, so now give me a point that lies on the parallel line. Well, I mean, yeah, there's so many points you could choose. I mean, right here, there's a point right there. You would be -5, 1, 2, 3, 4, -5, up 4. So -5, 4, that's 1 point. There are a lot of different points, but that's one. I could probably choose this y-intercept right here of 1, 2, 3, 4, 5, 6, 7. No, that's not quite it. Never mind. Oh, I know. I could choose this point here, 1, 8. So over 1, up 8. Right? So I have a bunch of points that I could choose that are on that parallel blue line. The perpendicular line, I mean, well, one point that stands out right here is that y-intercept of 0, 3. Right? And again, there's other points too, several other points. But we wanted one line that was parallel with the same slope and one line that was perpendicular with a negative reciprocal slope. Okay, now we get into our reasoning section. It says, are lines AB perpendicular if the points defining the lines have the coordinates A, 3, -2, B, 6, 13, C, -5, 8, and D, 5, 6. Justify your answer. Okay, so let's find the slope of these first. So AB, find the slope. Okay, and then CD, we're going to find the slope. So the equation is y2, so I'm going to go x1, y1, x2, y2, and then for CD, do the same thing. x1, y1, x2, y2. Okay, so starting with the first part, so y2, that's 13, minus y1, that's minus a -2, over x2, which is 6, minus x1, which is 3. You can see minus a minus there, so that's plus. And we have 13 plus 2 is 15, over 6 minus 3 is 3, and we get a slope of 5. Okay, now if I do the second one, I have y2, that's 6, minus y1 is 8. And then x2, that's 5, minus x1, which is a -5. So minus a minus again is plus. So 6 minus 8 is -2. Over 5 plus 5 is 10. Reduce this to a lowest terms by dividing top and bottom by the largest number that goes into both of them, which is 2. And we get a negative number, -1/5. Now look at the slope. Since 5 and negative 1/5 are negative reciprocals, line segment AB is perpendicular to line segment CD. And that's how you can prove it. So since the slopes of the lines are perpendicular, negative, they're negative reciprocals of each other, they must be perpendicular. Question 7. So in triangle EFG, let's go ahead and plot those points so we can see the triangle, okay? So we're going to provide proof of a yes or no answer. Is it a right triangle? And it says use of the grid is optional. So we could use our slope equation, right? Y2 minus Y1 over X2 minus X1, or we could just plot the points and use rise over run. I tend to think that works a little bit faster, more efficient, so I'm going to do it that way. Let's plot point E. So go -2, that's there. Up 7, that's there. There's point E. So point E will be -2, 7, right there. G is -6, -3, so -6, -3, that would be this point here. That's point G. -6, -3. And point F, we're going to go over 7 and then down 8. So over 7 is right there, and then down 8 would be all the way down here. Okay, that it would be point F of 7, -8. And go ahead and complete the sides to that. Just go ahead and draw lines in between them, just like that, and we'll just kind of make the triangle shape. And we're trying to see, is that a right triangle? Well, the only way that could be a right triangle is if this angle is a 90-degree angle, meaning is EG perpendicular to FG or GF? No, FG. Are they perpendicular? And that's what we're going to find out. So we're going to find out the slope of EG. So the slope of EG we go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We go over 1, 2, 3, 4. Up 10 over 4. Divide top and bottom by 2 to reduce it to lowest terms. And we have a slope of 5/2. Okay, that's not my answer. It's just going to help me create a conclusion to my answer in a second. So I got the first slope. Now I need to find the slope of that one there of FG. So for that one, I'm going to have to go down and over. So I'm going to go down 1, 2, 3, 4, 5, and then over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Down 5 over 13. These slopes are not negative reciprocals of each other. They're not even reciprocals of each other. Okay, so what is our conclusion? That EG is not perpendicular to FG. What does that mean? Triangle EFG is not a right triangle. Because if it's a right triangle, it has to have a right angle. Okay, and then part 8, number 8, if point H lies on EF, okay, so here's segment EF, point H is somewhere on there, right there. And so point H lies on EF of the triangle above such that GH is perpendicular to EF. What is the slope of GH? So GH is going to be a line that's going to be going in that direction there. Whoops. So first things first, we need to find the slope of EF. That's first. Then what we need to do is we will find a negative reciprocal of that slope, and that's going to be the orange line, which is GH. So EF is the blue line, GH is the orange one. So we got to find the slope of the orange line. Okay, so first find the slope of the blue line. So how do we do that? We're going to go from E all the way to F. Let's zoom in. We're going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, down 15, over 1, 2, 3, 4, 5, 6, 7, 8, 9. So down 15 over 9. So for EF, the slope is down 15 over 9. Reduce that. Largest number divided into both is 3. So we get negative 5/3. So that's the slope of that. Now, GH has to have a perpendicular slope, which would be a negative reciprocal of that. So take the reciprocal, 3/5, and we're going to change the sign from negative to positive. So how do we do that? First of all, what is the slope? The slope is going to be negative 3/5, and then we're going to draw GH on that. How do we do that? We're going to go from point G right there, up 3 over 5. It would look like this. From here, we're going to go up 1, 2, 3, over 1, 2, 3, 4, 5. Draw a line through those points. And that blue line right there is line segment GH. And you can see this line is perpendicular to that line, meaning it intersects at a 90-degree angle. I hope you found this tutorial to be helpful. Remember to pause, go back, and look at this at your own pace. Thank you, and see you next time.